Good morning, student, and welcome in online lectures. In last lecture, we have seen the empirical formula and molecular formula from the same chapter, that is the Introduction to Analytical Chemistry. Now, in this chapter, the last topic is the concentration and different ways of expressing concentrations. Now, first of all, understand what it means by concentration. Concentration. Concentration is nothing but the amount of substance present in given quantity of solvent or given quantity of the solution. Now, there are number of ways of expressing the concentrations, such as first percentage by mass. This is the first way of expressing the concentration. Which one? Percentage by mass. It is also called as percentage by weight. Percentage by weight. This is the one way to express the concentration of the solution. Then second, mole fraction. Mole fraction is the another way of expressing the concentration of the solution. Then third way, molarity. Molarity. And fourth one, molarity. Molarity. There the one more, that is the ppm, that means part per million. But only these fours are included in this chapter. Now, one by one. First of all, about the percentage by mass. How to calculate the percentage of mass of substance? Percentage by mass is nothing but the ratio of mass of solute to the mass of solution multiplied by 100. Means what? Here percentage by mass. Percentage by mass is nothing but mass of, that means we can write here is equal to mass of solute divided by mass of solution. Mass of solution and multiplied by 100. This is the formula to calculate the percentage by mass or percentage by weight. What is it? Mass of solute divided by mass of solution multiplied by 100. For better understanding, we can consider the one example. For example, suppose we have given 60 gram of glucose. What we have given? 60 gram of glucose, and it is dissolved in, suppose, 500 gram of water. And the question is asked, calculate the percentage by mass of glucose in a given solution. Now, according to the formula, percentage by mass of glucose. Glucose. Here, what we have given, 60 gram of glucose is nothing but the mass of the solute. And then from this, here, mass of Water is also given. And from these two, we can calculate the mass of the solution. Here, 60 is the mass of the solute. And mass of solute plus mass of solvent is nothing but the mass of the solution. That means here 60 divided by 60 plus 500. That means 60 divided by 560 is the mass of the solution. The mass of the solution become here 500 gram is the mass of the solvent, that is the water, and plus 60 gram is the mass of the solute. Therefore, total mass of the solution become here 560 and here multiplied by 100 according to the formula, multiplied by 100. And by solving this, what we get here? This 0 and this 0 get cancelled. What is remaining here? 600 and divided by 56. And when we calculate it, what we obtain here? 56, 1, 0, then 7 and 1. This is the percentage by mass of glucose in the given solution. Now suppose we have given the percentage and the mass of the solution. By using this, we can calculate the mass of the solid. Sometimes some type of questions may be asked in exam. For example, here we have given what percentage of mass is given. Percentage of mass is given. Suppose it is given 4.8 and mass of solution is also given. Suppose here we consider mass of solution. Mass of solution. Suppose we consider here 600 gram. And in this problem, we have to calculate. What we have to calculate? Mass of the solute. Because it is not given in this problem. In this problem, what given? Percentage of mass and the mass of the solution. Therefore, according to formula, what we can write here? Percentage by mass is equal to mass of solute and divided by mass of solution, mass of solution multiplied by 100. This is our formula. And here percentage by mass is given. What is it? 4.8. Therefore we can substitute here 4.8 is equal to mass of solid is not given in this problem. Therefore we can assume it x. Suppose x multiplied by 100 and divided by mass of solution. It is given 600 gram. Therefore we can write here 600 gram. Cancel these two zeros with these two zeros. What is remaining here? 4.8 is equal to x upon 6 or we can write here x is equal to what we get here x is equal to take this 6 to the left hand side, therefore here 4.8 multiplied by 6 and by solving this we get here 28.8 gram of solute present in the given 60 gram of solution. In this way, you can calculate percentage by mass by using this formula. Percentage by mass is nothing but the mass of solute divided by mass of solution multiplied by 100. This is the first way to express the concentration of the given solution. This is the one way of expressing the concentration. Concentration is nothing but the amount of the substance or amount of the solute present in a given amount of the solvent. Amount of the solute present in a given quantity or amount of the solvent is nothing but the concentration. And this is the first way. Percentage by mass, or it is also called as the percentage by weight, is the first way of the expressing the concentration of the given solution. Then second thing, that is the mole fraction. Mole fraction is nothing but the number of moles. Mole fraction is nothing but the number of moles of constituent. Particular constituent is the ratio. Mole fraction is nothing but the ratio of number of moles of particular constituent or component to the total number of moles of the solution. Means what? Suppose when we consider here two components, second mole fraction. Two components, suppose A and B are the two different components which are present in a solution. Now, for first component, suppose we assume Na be the number of moles, be the number of moles of A. That is the first component. And suppose Nb the number of moles of B. That is the second component. And the total number of moles of the solution will come. Total number of moles of solution become Na plus Nb is the total number of moles of the solution. And according to the definition, what is the mole fraction? Mole fraction is nothing but the ratio of number of moles of constituent to the total number of moles of the solution. That means here for the component A, mole fraction, mole fraction of A is given by, according to definition, the number of moles of A is nothing but Na and divided by total number of moles of the solution is nothing but Na plus Nb, and therefore here Na plus Nb. Na plus Nb for the first component, that is the A. Then mole fraction for B. Mole fraction of B. We can write here Nb and divided by total number of moles of the solution, that is Na plus Nb. Understand? What is the mole fraction? Mole fraction is nothing but ratio of number of moles of particular constituent to the total number of moles of the solution. Now, or in other words, we can say here, suppose A is the solute and B is the solvent. Then number of solute, here number of solute divided by total number of moles of the solute plus solvent. Same way, suppose this is the B is the solvent. Then it becomes number of moles of the solvent divided by the sum of number of moles of solute and number of moles of the solvent. For the better understanding, we can consider the example. Suppose we have given 60 gram, not 60 gram. Suppose we consider any one example can consider, suppose we have 64 gram of methyl alcohol and it dissolved into, suppose, 500 gram of water, and we have to calculate the mole fraction of the methyl alcohol as well as the mole fraction of the water in a given solution. Now suppose here 64 gram of methyl alcohol is given to us and 500 gram solvent is given to us. Now first of all, we have to calculate the number of moles of what methyl alcohol, and then we have to calculate the number of moles of the water, and then we can calculate the mole fraction of the methyl alcohol and mole fraction of the water. Now, first of all, calculate the molar mass of both. Molar mass of the methyl alcohol and the molar mass of H2O. Why it is necessary to calculate the molar mass of the methyl alcohol and the water? Because of here number of moles of methyl alcohol is nothing but the mass of methyl alcohol divided by its molar mass. Means here number of moles of methyl alcohol can be calculated from the mass of the methyl alcohol and its molar mass. So number of moles of, first of all we calculate the molar mass of both. Molar mass. Here molar mass of methyl alcohol CH3OH is the formula for methyl alcohol, and from the formula we can calculate for carbon 12 plus there are 4 hydrogen, so 4 and plus only one oxygen, that is the 60. 6 plus 4 10, 1 2 3 32. 32 is the molar mass of the methyl alcohol. Similarly, we can calculate the molar mass of the water. Molar mass of the water. Molar mass of H2O. Here there are 2 hydrogen and only 1 oxygen. Therefore 2 plus 16, that is equal to 18. Here 32 is the molar mass of the methyl alcohol and 18 is the molar mass of the water. And from this we can calculate the number of moles of the methyl alcohol and the water. Now see here molar number of moles of methyl alcohol, mass of methyl alcohol is given to us, that is the 64, and molecular mass we have calculated here, that is the 32, and therefore it will become 2. That means number of moles of methyl alcohol obtained here 2. Similarly, we can calculate the number of moles of water. Here number of moles of water H2O. Here mass of water is given to us 500 gram and its molecular mass we have calculated here. Therefore here 500 and divided by 500, not here. We can change the value, suppose here 90 gram for the better understanding and for the simplest calculation. Suppose here 90 and divided by 80. Here suppose What we get here? 5. For the simplest calculation here, we have changed this value. Now, number of moles of water is obtained, number of moles of alcohol is obtained. Then we can calculate the mole fraction of the methyl alcohol and the mole fraction of the water. First of all, about the mole fraction. Mole fraction of methyl alcohol is equal to, what is the formula? Formula is number of moles of methyl alcohol divided by total number of moles of the solution. Here suppose one more, total number of moles become here 2 and plus 5 is nothing but the 7. Now here number of moles of methyl alcohol obtained here 2 and the total number of moles which are present in solution become 7. Therefore, here 2 divided by 7. 2 divided by 7. Same way here, mole fraction of water, it become 5 divided by 7. Here 0, 2, then 8, 6, again 6, but instead of this we can directly write here 2 at 7. Okay, now here 0.7, 1 and then 3. This is the mole fraction of water. 7, 1, 3, 2 and 7. Now, when we add these two quantities, what we get here? 7 plus 3, 10. Here 1, 8 plus 2, 0. Here 1, 8 plus 2, 10. 1, 2, 3, 1, 2, 3. Here 1. We get here 1. That means the mole fraction of solute and mole fraction of solvent is always equal to 1. It is always equal to 1. When we consider the mole fraction of methyl alcohol, suppose XA, and that of the water is suppose here XB. Then XA plus XB is equal to 1. That means, please remember this point. Here, mole fraction of solute and the mole fraction of solvent. That means the sum of mole fraction of solute and mole fraction of solvent is always equal to 1. For the better understanding, we can consider the one more example. For example, suppose we have given, suppose we have given 23 gram. We can take any values for the problem. Suppose here 23 gram of ethyl alcohol, C2H5OH, and it is not into suppose 54 gram of the water, which is given to us, and we have to calculate the mole fraction of both ethyl alcohol as well as the water. Now, first of all, the molar mass of ethyl alcohol, that of water is known to us. Therefore, only for the molar mass of ethyl alcohol, C2H5OH. Therefore, we can calculate. There are two carbon, therefore 12 multiplied by 2 plus 5 plus 6 hydrogen plus 6 and only one oxygen. That is equal to 6 and 6, 12 and 24. That is the 46. 46 is the molar mass of the ethyl alcohol. Now, first of all, calculate the number of moles of the ethyl alcohol and that of the water. Number of moles of ethyl alcohol. Number of moles of ethyl alcohol. The mass of ethyl alcohol is given 23. And we obtain the molar mass of ethyl alcohol from the formula. Therefore, here 23 divided by 46, it becomes 1 half, that is equal to 0.5 is the number of moles of the ethyl alcohol in this problem. Now, number of moles of the water. Number of moles of water, that is the H2O. The mass of water is given 54 and its molar mass is nothing but the 18. 2 plus 16, 18, and it becomes 3. 3 is the number of moles of the water. From this, we can calculate the total number of moles solution. Total number of moles present in solution become 0.5 and plus 3, that is equal to 3.5. This is the total number of moles of the solution. Now, mole fraction of ethyl alcohol. Mole fraction. Mole fraction of ethyl alcohol according to the formula. Here, number of moles of the ethyl alcohol divided by total number of moles. That means here we can directly write here 0.5 divided by 3.5. Okay. And that of the mole fraction of water. Number of moles we obtain here 3 and divided by 3.5. 3.5. Here, suppose 0.14 and 3. And here, 0. We calculated here. The value of the is nothing but 143 is correct one. And next one is the 857. We will calculate 857. And now again, when we add these two mole fractions, we should obtain 1, isn't it? Now see here, 7 plus 3, 0, 1, 6 plus 4, 0, here 1, 9 plus 1, 0, 1, 2, 3, 1, 2, 3. We obtain here again 1. That means the mole fraction of solute and the mole fraction of solvent. The sum of mole fraction of solute and mole fraction of solvent is always equal to the 1. Isn't it? In this way, the second ways of expressing the concentration is nothing but the mole fraction. Mole fraction is nothing but the ratio of number of moles of particular constituent to the total number of moles of the solution. And in this way, we can find out the mole fractions. Now, third, that is the molarity. Molarity. There is always one question on the molarity or something on the molarity also. Now, Molarity. Molarity. Third. Molarity is nothing but the number of moles present in 1 liter of solution. Means what? According to definition, we can write molarity is equal to number of moles. We can write here is equal to number of moles divided by volume in liter. Volume in liter. This is the formula for the molarity. Molarity is nothing but number of moles per liter. It's called as the molarity. This is the third way of expressing the concentration of the solution. Now, how to calculate the molarity? Suppose we have given one problem. Suppose 20 gram of 20 gram of NaOH dissolved in 2 liters of solution. 2 liter of solution, that means 2 liter of water. 2 liter of water. 2 liters of water. And we have to calculate the molarity of the solution. Now, according to definition, molarity is nothing but the number of moles and divided by volume in liter. Therefore, first of all, we have to find out the number of moles of the NaOH. And for that, first of all, we have to calculate the molar mass of the NaOH. So, first thing, molar mass of NaOH. Molar mass of NaOH. We can calculate from the formula for the sodium 23, for oxygen 16 and for hydrogen 1. That is equal to 40. 40 gram is the molar mass of the NaOH. And the mass of NaOH is given from the mass of NaOH and from the molar mass of NaOH. We can calculate the number of moles first. Number of moles of NaOH, that is equal to mass of NaOH is given, mass of solute. We can write here mass of solute divided by molar mass of solute. Molar mass of solute. And therefore here, instead of this, we can write here NaOH, mass of NaOH. And here also, instead of this, we can write the molar mass of NaOH for the simplicity. Now see here, 20 gram is the mass of the NaOH. We can write here 20. And molar mass of the NaOH, we have calculated here from its formula, that is the 40. Cancel this 0. What we get here? 1 half. And is nothing but the 0.5 is the number of moles of what? NaOH. And then we can calculate the molarity according to the formula. Molarity of NaOH. Molarity of NaOH is equal to number of moles of NaOH divided by volume in liter. We have given here 2 liter of water, that is its the volume in liter. And so we can write here 0.5 is the number of moles of NaOH obtained here divided by volume given 2. And therefore it becomes 0.2 and 5, isn't it? 2 and 5. This is the molarity. And here you should write capital M is the unit of the molarity. And the molarity is depends on the temperature. Why so? Because of as temperature changes, the volume of the solution also changes, and that's why it is a depends on the temperature. Now, for the better understanding, we can consider the one more problem, that is suppose 49 gram. Suppose second problem. Suppose 49 gram of H2SO4 dissolved into suppose 4 liter of the solution, and you have to calculate the molarity of the sulfuric acid in given volume. Now see here, first of all we have to calculate again the molar mass of the sulfuric acid. Molar mass we have to calculate first. Molar mass of H2SO4 according to the formula 2 plus 1 sulfur 32, and there are 4 oxygen, therefore 64, and when we 6 8, that is the 98. 98 is the molar mass of the sulfuric acid. Now from this we can calculate the number of moles of H2SO4, number of moles of H2SO4. Mass is given, that is 49, and molar mass we have calculated here 98, and therefore 1 half the, and it becomes 0.5. Okay, this is the number of moles of the sulfuric acid, and from the number of moles of sulfuric acid we can calculate molarity. Molarity of sulfuric acid H2SO4. Molarity is nothing but number of moles divided by volume in liter. Here number of moles we have taken here 5, and total volume is given to us here 4 liter, and therefore it becomes 0.125. Okay, this is the next. Now last one is the molarity. Last one is the molarity. Molarity is nothing but fourth way. That is the molarity. Fourth way. Molarity is nothing but the number of moles of the solute divided by the mass of solvent in kilogram. Mass of solvent in kilogram means what? Suppose here from the definition we can write molarity. Molarity. Molarity is nothing but number of moles of solute divided by mass of solvent in kilogram. Mass of solvent in kilogram. Now suppose according to this we can solve one problem. Here suppose we have given 15 gram of urea. Suppose we have given here 15 gram of urea, and it is dissolved into suppose 600 gram of water, and we have to calculate the molality of this solution. Now first of all, for the number of moles of the solute, we have to calculate the molar mass of the urea, and the formula for the urea is COH4 and N. Or we can write the structural formula even suppose here CO NH2 and on left hand also NH2. This is the formula for the urea. And from the formula of urea we can calculate the molar mass. See here there are only one carbon, so we write here 12 plus only one oxygen, we can write 16 plus there are two nitrogens, here one, here one, two nitrogen, therefore 28 and plus there are total four hydrogens, 4 and it becomes 60, isn't it? It becomes 60 and from this molecular mass we can calculate the number of moles of the solid, that is the urea. Number of moles of urea is equal to mass of urea divided by molar mass. Mass of urea is given 15 and molar mass we have calculated here 1/4 and that is equal to 1/4 is nothing but 0.25. 0.25 is the number of moles of the urea and mass of the solvent in kilogram. Here mass of solvent is given 600 gram but it converts to in kilogram. Therefore molarity becomes molarity. Number of moles here 525 and divided by this 600 multiplied by 10 raised to minus 3. Why so? Because of solvent must in kilogram. Therefore, here 10 raised to minus 3. And by solving this 0.25 multiplied by, take this 10 raised to minus 3 to the upper side, it becomes 10 raised to 3 and divided by 600. And by solving this 0 point instead of this, we can write here 250 divided by 600. By solving this, we can obtain the molarity. We can cancel this one and we can write here suppose 0.417 is the molarity and the unit of molarity is a small m and it is independent of the temperature. In this way, there are total four ways of expressing the concentration of any solution, such as first is percentage by mass, then mole fraction, then molarity, and last one is the molarity. In this way, this chapter is over only 2 points, that is the limiting reagent and excess reagent. You may read from the your textbook, only two definitions are remaining. Definitions are very easy. You can read from your book. Okay, we stop here.